Okay, so here we can see that we have an equation and we're adding two fractions, and they tell me what the answer is after I add, which is 11 over 12. So what you need to do is figure out the x, this denominator here, that makes this equation work. Now remember, when you add two fractions, you need a common denominator. So go ahead and maybe try, pause this video for a sec and try a few numbers out that would make this fraction work. Now, for me, I'm going to go ahead because I've already figured out the number that makes this work. So if I try 6 here, let me try that out. So if I make this x a 6, let's see if this gives me 11 over 12. Now, I tried out a bunch of numbers previous of this. Basically, I thought of factors that give me 12, like 2, 4, 3, and 6. I'd even tried 12. And from those numbers, 6 is the one that worked, and I'll show you why. So when I look at this fraction here, I know I need to multiply 3 to this 4 to make it a 12. And so I need to multiply the top by 3. So that's what I'm going to do. To get 6 to be a 12, I need to multiply by 2. So 2 in the bottom, 2 in the top. And when I multiply, I already know my common denominator needs to be 12. Oops, my bad. 12. And so 3 times 3 gives me 9, plus 1 times 2, which is 2. So when I look at the top here, 9 plus 2 gives me 11. So I have 11 over 12. And that's the answer that I had in the beginning. Okay? So you can do this guess and checking until you get the right answer. However, this took a while, right? So one way you could do this problem more systematically and more efficiently is to try to get a common denominator for all three of them and still using that variable x here. Okay, so that's what I'm going to do here. I'm going to erase my work to do this in a different way. Okay, so what I'm going to do first is find a common denominator. And to be more efficient, I'm actually going to find the least common denominator, or in other words, LCD is what I can also represent it as. So the least common denominator is basically the common denominator that takes the least amount of multiplying to get to. So what do I mean by that is, well, if I take a look at all three denominators, I have a 4, an x, and a 12. Now first, I'm going to just take a look at the numbers. I have a 4 and a 12. What can they both be? So you can multiply to get up to that number, but you can't ever divide or like subtract or anything like that. So 4, I know for sure, can be a 12 if I multiply it by 3. 12 is already a 12, so my least common denominator for the 4 and the 12 is 12. And then I have an x, so I need that factor as well, so I need a 12x in this case. So that means I need to multiply whatever's in the denominator by what it's missing to get to that 12x. So like I have a 4 here. What do I need to multiply to the 4 to get a 12x? Well, I need to multiply it by a 3x. So I need to multiply the top by a 3x. So you need to multiply the bottom to whatever you need to get to that least common denominator. I'm not doing that for all the denominators. So like for this x here, to make a 12x, I need to multiply the top and bottom by 12. For this last denominator, I already have a 12, but I don't have an x. So I'm going to multiply the top and bottom by x. From here, the top, I have a 9x. And then for the bottom, 3 times 3x times 4 gives me 12. Oh, my bad. 12x. Let me write in all the denominators first. How about that? Because in this case, all the denominators are going to be the same. So 12 times x, 12x. 12 times x gives me 12x. For that last one. And then for the top here, 12 times 1 gives me 12. And then 11 times x is 11x. So you can see here the denominator are all the same. Actually, you know what? I can do this. So notice that the denominator is all the same. So guess what? This cancels all out. And that means I'm just left with the top here. Just this part. So I'm going to grab the numerator because that's all that I have left now. So once you get all your denominators to be the same, you just have to look at the numerator to solve. So that means I just have 9x plus 12 equals 11x. And so if I want to figure out what x is, all I got to do is get x by itself. This is a normal algebra problem. So maybe I'm going to subtract the 9 over to both sides. That would cancel out this guy. So I'm left with a 12 equals 2x. And then I would divide by 2. 2's cancel. And so x is equal to 12 divided by 2, 6. And that is the same answer we got from guessing. But this is more efficient. It does take a bit longer. Sometimes guessing is faster. But when you get to really complicated fractions, guessing is not going to be guessing is not going to be efficient at all. So we're going to do problems very similar to this where we're having to solve for x with fractions. All right, so we're going to head into our lesson for today. All right, so solving rational equations. What you got to do to solve rational equations is you have to make sure you have the least common denominator, or the LCD is what we could also call it. Because that allows us to cancel all the denominators out, and then we're just dealing with that numerator. So that means that the fraction is gone. And that makes it a lot easier to solve when you're not dealing with fractions. I think you guys could probably agree with that, because most of you guys hate it when I have a fraction in a problem. All right, also, another thing, when you're solving for x, you need to check your answer, okay? And the thing about fractions is the denominator should never be 0. Because if it is, then it's no solution. And here's why. Let's take a look at zeros because they're really interesting when they're in fractions. So when you do 0 over, let's say, a number like 7, so this is really saying 0 divided by 7. Well, 0 divided by 7, or by any number, is 0. So when 0's in the numerator, it's 0. But let's think about the other way around. What is 7 divided by 0, where the denominator has a 0. So that's kind of going into why this is a no solution. Well, if you put this in your calculator, it's going to throw you an error because it's undefined. You cannot divide by 0, okay? And here's why. Think about it. If you have 0 cookies and you have 7 friends, how many cookies does each friend have? Well, you got 0 cookies, so no friends, none of your friends are going to get cookies, basically. And this makes sense why this is 0. But when you have 7 cookies and no friends, well, this doesn't make any sense. Why are you doing any type of sharing? So this is undefined. So hopefully that gives you a real world example to look at why you cannot divide by 0. So let's look at this problem here. Notice that the denominator here are all different and we're adding. So that means that if I'm adding, I need a common denominator. So that's what I'm going to do first, is figure out the least common denominator, or the LCD. So my LCD here, if I think of the numbers first, like 2 and the 10, they're just numbers. Whereas x plus 3, you can think of that as like a factor. So I'll put that in parentheses. As basically when I ever have like a x or an expression that has a variable, I just make that as a factor. Whereas the 2 and the 10 are numbers, so I have to think of the least common denominator for those two first. So what I do is that I know the least common denominator has to be at least a 10. And so I ask myself, can 2 be a 10? Yes, if I multiply that by 5. So in this case, my least common denominator is 10. And then I have this factor x plus 3, so I'm going to take all of that and put that in my least common denominator. Okay, So it looks like my LCD is 10x plus 3. So I need to make sure all the denominators are the same. Okay. So you might have saw me multiply the so in the bell work here, this x plus 3 already, so this denominator already has an x plus 3, so it needs to multiply by a 10, top and bottom. So the top and the bottom both get a 10. Whereas this one here has a 2, so I need a 10x plus 3. So first of all, to get to the 10, I need to multiply by a 5. And then to get the x plus 3, well, I need an x plus 3. And so I need to multiply the top by x plus 3. Looks a bit squished. Then for this one here, I have a 10, but I don't have an x plus 3, so I need to multiply by x plus 3. So the top and bottom. Now, just to save me a bit of writing and time, I'm not going to multiply out the bottom, because I can already see if I multiply out, I should get 10x plus 3. So because I know that once I get all of the denominator to be the same, they cancel, I'm just going to now drop the denominator here, just because it saves me a bit of time. And I'm just going to focus in on the numerator and multiply that all out. So 10 times 2, that gives me 20, plus 3 times 5 is 15. And then there's this x plus 3 next to it, so I'm going to bring that down. And then this one here, 19 and x plus 3, so I'm going to bring that down. And now I'm going to try to solve for x. So one thing I noticed is that they both have a number outside the parentheses, so it might be good to just first distribute that into the parentheses. So I'm going to go ahead and do that. So I have 20 plus 15x plus 15 times 3 gives me 45. 19 times x gives me 19x. And 19 times 3, well, that's 57. From here, I'm going to try to get all the x's on one side, but let's try to collect any like terms here. Like the 20 and the 45 are both numbers, so I can combine them to make 65 plus 15x that I'm going to drop. Perhaps let's move the 15x over to the other side. That would cancel. So I have 65 equals 4x plus 57. And so I could subtract 57 from both sides. This cancels. And so 65 minus 57 is 8 equals 4x. And so to get the x by itself, I need to divide by 4. So I'm going to divide 4 by both sides. And so 8 divided by 4 gives me x equals 2. But hold up, this is not the final answer, because you got to make sure you check if this causes the denominator to be 0. So when you look back at the original problem, I know it's kind of a mess here. But if you look back, notice that this denominator here had an x plus 3. So if you put in 2 into this x here, 2 plus 3 gives you 5. 5 is not 0, and so in this case, this is a valid solution. Notice the other denominators here didn't have an x to plug in, so you wouldn't plug it in there. You only plug it in if you see a denominator being x in it, so you would plug that in to check. Okay, so now let's try a few more problems. Okay, so for part A, I'm going to be combining these fractions by subtracting. So just like before, I'm going to need to find a common denominator. But first thing that I noticed when I looked at this problem is that I see a factor. Actually, let me use a pen. These are factors, x plus 1, x minus 1. But this one here is a quadratic, x squared, right? So remember, when we see a quadratic, we probably should factor, because that allows us to get its factors. So that's what I'm going to do first before I do anything. I'm going to bring down the original problem, but I'm going to factor that piece right there at the end. So everything stays the same. The only part I'm doing is factoring that x squared minus 1. So to get that, I can factor it to be x minus 1 and plus 1. Notice when you multiply, you get that negative 1, but when you add, it cancels out the middle term. So that's why there's no middle term here. So I factored. Notice when I do this, I can see that I have some repeats of factors. That's going to help me out when I make my least common denominator. So my LCD, let's figure that out. So you need a copy of each factor. Okay, so I'm going to go through this from the first fraction. I need an x plus 1 here. So I'm going to put in an x plus 1. I need a x minus 1, so I'm going to put in an x minus 1. Then when I look at this side here, I need an x minus 1, but I already have it. Whereas this one, I have an x plus 1, but I already have that. So you only need one copy of each factor. When I look at this, I'm going to try to get the denominator to all be the same. So I have to figure out what do I need to multiply to the top. Like this one here is already an x plus 1, so I need to multiply to this one an x minus 1. Whereas this one, I need an x plus 1 because the denominator only has an x minus 1, so I'm missing the x plus 1. But the last one here, it already has both of the factors, so guess what? I don't need to multiply anything. This is negative 2. So once I get all the denominators to be the same, then that means I can ignore the bottom. So I can cancel out the bottom and just focus in on the top because I've already multiplied the top, whatever the denominator was missing. So the top here is really just 2x minus 1 minus negative 1 x plus 1 equals negative 2. So just like before, I'm going to distribute the numbers. Oh, notice that you have a negative 1 in front of this parentheses. So make sure you distribute that negative sign. So if I distribute, I have 2x minus 2, negative 1x, negative 1 equals negative 2. Now I'm going to combine any like terms that I see. I see a bunch on this left-hand side. So these two can combine. These numbers can combine. So 2x minus x is 1x. Negative 2 minus 1 is negative 3 equals negative 2. If I add 3 to both sides to get this x by itself, x is equal to 1. All right, so looking at this here, I have a x equals 1, so I have to go back and see if this doesn't give me a denominator of 0. So when I plug 1 into the first one, 1 plus 1, 2. This one's okay. 1 plugged into this one, 1 minus 1, oops, that gives me a 0. So this becomes an invalid answer. So in this case, I have a no solution here. So if you get a denominator to be 0, then that means it's no solution. Also, I just want to mention, to make this a little bit easier, or for you guys to be more aware, take a look at the denominator here. You kind of can already sense what the denominator, what that x needs to be for it to not work out. Like if this x was a negative 1, this would have not worked because negative 1 plus 1 makes a 0. If this x was a 1, this makes it a 0. So that's why, like in the beginning, when I was working it out, when I got that x1, I could already sense that this x was not going to work out. But if you aren't for sure, just plug it in and see if that's the case. All right, let's move on to B here. So B has some few factors down here. There's two factors, x and x minus 2. You have an x here and an x minus 2 here. So let's figure out our least common denominator first. That's where I usually start out. So looking at this here, I need an x. So I'm going to pop an x here. I need an x minus 2 because that's what I have on this fraction. So I'm going to put in x minus 3. For this fraction, I need an x, but I already have an x. And then this one, I need an x minus 2, but I already have an x minus 2. So this is it for my least common denominator. So now I need to multiply the top, whatever I'm missing. Well, the first one here already has everything. So I don't need to multiply anything to this 3x. Whereas this one here, I have an x. It's missing an x minus 2. So guess what? The top needs an x minus 2. You might be noticing I'm not multiplying it now to the bottom, and that's just because I'm a little lazy. Because I know the bottom, if I multiply, everything's going to cancel out. But feel free to write in that you're multiplying to bottom if you want to, be more, better at bookkeeping and everything, and you want to see everything laid out. I'm just a bit fast, that's all. So this one here has an x minus 2, so I need to multiply the top and bottom by x because that's what it's missing. So I multiply the top by x. So now that the denominators are all the same, because I've multiplied it, I figured out what to multiply to the bottom, and I did it for the top. So now I'm just going to look at the top here. So I have a 3x in the top minus 4x minus 2 equals 8x, or 18x. So from here, I'm going to try to solve this out. Like, I have a negative 4 in front of this parenthesis, so I'm going to make sure I need to distribute. Make sure you distribute that negative sign. So I have 3x minus 4x plus 8 equals 18x. From here, I'm going to combine any like terms like these two. That makes a negative x. Ooh, this just got a little bigger. Plus 8 equals 18x. So if I maybe add x to both sides, that cancels, and I just have 8 equals 19x. I'm going to divide by 19. So x is equal to 8 over 19. Got a fraction here, so not as a pretty number as before. But when I look back here, if I plug in this fraction, I don't really cause anything to be a 0. Because first off, when I look at this problem here, this factor has an x minus 2. What does this x need to be to make this factor 0? Well, that's positive 2. Because if I do 2 minus 2, that gives me 0, and that would cause this to be a no solution. Whereas if I have an x here, if I kind of ignore this part here, just let me take a look at this one. If I have an x here, well, the denominator needs to be, x needs to be 0 to make this denominator not work. So my answer is not a 2 and it's not a 0, so I know that this is going to be valid. Okay. But if you're not comfortable with that, you could just plug it in and see if the bottom gives you 0. Okay, so last problem here. When I'm looking at this one, it's quite a doozy, but remember to focus just in the denominator first, because you're going to need to find the LCD. So what I notice when I look in the bottom is that these two on the side are factors, but this middle one here is a quadratic. So I need to foil that first, or sorry, not foil that, factor that first to figure out what factors it might be composed with. So that's what I'm going to do first. I'm going to bring down everything else just the way it is, but I'm going to factor that denominator. I also like to mention I'm not factoring this numerator here, even though it is a quadratic, because there's no point in getting factors for the numerator. I'm only finding factors because I want a common denominator. Like I said, numerators we're just going to combine later, so there's no point in factoring the top. You can, it's just not necessary, and in my personal opinion, it slows down the calculation. So factor the bottom, because we need a common denominator. So if I want a 15, but two numbers to add to give me 8, maybe 5 and 3 will work. Right? Because 5 times 3, 15. 5 plus 3, 8. So when I look at this here, I can sense that my LCD, or my least common denominator, is going to be an x plus 5 and an x plus 3. And then this middle one already has these two terms. So I look here and I see an x plus 5. So I need an x plus 5. This one already has an x plus 5, so I don't need a second one. This one has an x plus 3, so I need an x plus 3. And this one has an x plus 3, but I already have that. So I don't need another copies. Okay, so here we go. We're going to multiply the top by whatever's missing in the denominator. Like this one here has an x plus 5, so I need an x plus 3 in the top. So I'm going to multiply the top by x plus 3. This fraction already has everything in the least common denominator. So in this case, I don't need to multiply anything to the top. Whereas this one here has an x plus 3, so I need to multiply the top by x plus 5, because that's what it's missing. Now, once you figure out what you need to multiply to the top to get a common denominator for the bottom, just ignore the bottom, cancel, because that cancels out, and so now you just have, let's see, 2x, the top, x plus 3, minus, oh, you know what? Because there's a minus sign here, right? There's a minus sign here. Make sure you distribute that minus sign to each factor, because what I notice is when you bring this down and then you bring this down, you often forget to distribute this negative because there was no parentheses around this numerator in the first place. So I like to distribute this negative into the terms as I write this down. So negative x squared, let me write that in black, plus x plus 10. So I've distributed that negative. Then I have a 3x plus 5. So now I'm going to distribute the stuff that's outside the parentheses. So that gives me 2x squared plus 3x, oh sorry, not 3x, 6x, 2x times 3 gives you 6x. Drag that down, x squared plus x plus 10. Then distribute a 3x plus 15. Okay, we got a lot of stuff going on the left side, so I'm going to combine any like terms that I see. So the x squares, if I combine, I get just 1x squared. If I combine the x's, I get 7x plus 10 equals 3x plus 15. So the first thing that I notice here is that I have an x squared in this problem. So that means I'm dealing with solving a quadratic. Solving a quadratic means that I have to get one side to be 0 in order to either 1, use the quadratic formula, or 2, factor. But I need a 0 on one side. So which is easier to do? Moving all of this stuff to that side or just this stuff to this side? Well, it's going to be this side moving to this side because there's only 2 terms. So I'm going to subtract off a 3x to that 7x, and I'm going to subtract off a 15 to the 10 because that allows me to cancel out the right side so that the right side is now 0. Let's look at what we have here. We have x squared plus 4x minus 5. And so now all I have to do is try to factor this quadratic. So 2 numbers that multiply to give me -5 but add to give me 4. Well, that can be positive 5 and -1. And so when I look at this here and I factored, all I got to do is set the factors equal to 0. So I'm going to do that here to the side. So I have x plus 5 equals 0 and x minus 1 equals 0. So if I subtract 5 from both sides, that cancels, so x is equal to -5. And if I add 1 to both sides, that cancels, and x is equal to 1. Okay, but hold up, we're not done. We got to check our answers. So take a look. I can already sense that when I look back in the original problem here, I have an x plus 5. So that means if I have an x minus 5, this is going to make it 0, which is not good. So I can tell already that this x minus 5 is going to be an invalid solution. The 1, on the other hand, I think we're okay because I don't see an x minus 1 anywhere. So like this here is, if I plug it in, 1 plus 5, that's fine. That's going to be a 6, a positive number. 1 plus 3, that's fine. It's not 0. And then these 2 got factored. If you plug it into here, it's going to be also okay. So this one here is a valid solution, but the x minus 5 is invalid because it caused the denominator to be 0. So hopefully that helps you with page 4 of packet 12. So now go ahead and go try some of the problems out in that packet.